we have given a semiconductor material. What we have to do in this experiment, we are changing the temperature of that semiconductor material, and we are observing the effect of that temperature on the resistivity of semiconductor material. So what we are doing, we are placing our sample in this oven, and this is a oven we are using to increase the temperature, and we are placing our sample in between this oven, and we are raising the temperature, and we are observing the effect of this temperature on the resistivity of this particular sample we are using, and the sample we are using of the semiconductor material. So in this experiment, we have to find out the resistivity of this semiconductor with the variation of temperature using 4 probe methods. We are using 4 probes to measure the voltage and the currents. So that's why it is known as the 4 probe method. And in this experiment, we have to find out resistivity of the semiconductor material. And we are using oven to increase the temperature. So these are some list of equipments that we are using to perform the experiment. Firstly, we are using power supply, oven, and we are using n-type crystal here. That is a semiconductor material we are using, and milliammeter and millivoltmeter we are using to measure current, and voltmeter. So these are some list of equipments we are using to perform the experiment using 4 probe method. And these are some pre-preparation for you, and you must have idea about fundamentals of semiconductors, difference between intrinsic and extrinsic semiconductors, and difference between conductors, semiconductors, and insulators, and what is the band gap of semiconductors. So these are some fundamentals and the idea you must have about these to perform the experiment. So what are 4 probes, and what is this 4 probe method we are using? So you can see here we have 4 probes, and these are equidistant from each other. And the 2 probes we are using, 2 outer probes we are using to measure the current, and the inner probes we are using to measure the voltage. And you can see here that these probes are connected to the material. So this is the material we are using, and this is the material we are using, and this is in form of very thin wafer, and this thin wafer is of the semiconductor material, and we are connected these 4 probes to this sample, and outer probes we are using to measure current, and inner probes we are using to measure voltage, and these probes are equidistant from each other. So why we are using this 4 probe method? 4 probe method is one of the standard and the most commonly used method for accurate measurement of resistivity. And in case of semiconductors we are using here in this experiment, so that also doesn't obey the Ohm's law, and because we know that conductors obey Ohm's law, and semiconductors do not obey Ohm's law. So here we are using the 4 probes and the accurate measurement of resistivity that we can measure from this 4 probe method. And it also overcomes the problem of contact resistance, and also offers several other advantages, and we can use a variety of shapes, and if you have any kind of shape of the material, you can use this method to find out the resistivity. And it can also measure wide resistivity range from micro ohms to mega ohm. But in case of when you use 2 probes, their range of resistivity you can't measure from micro to mega ohms, but in case of 4 probes you can use or you can find out the resistivity from micro ohms to mega ohm. And you also find out that the accurate value of resistivity you get from this experiment. And but when you are using 2 probes, the measurements you are getting, they are not very much accurate, and there is a large percentage of errors there in case of 2 probes. So now here is the oven that we are using to raise the temperature of the sample we are using, and here you can see This is the oven that we are using. This is oven, and we are placing our semiconductor material and sample in between this oven. And this is oven, and we are increasing the temperature of this sample. And you can see here there are some nodes are there, and we have a common controller over there. You can see we have a common controller, and from common controller what you do, you have range of oven there, and you can select the range of the oven. That if you are selecting, if suppose 200 degrees Celsius range, that means now oven will increase the temperature up to 200 degrees Celsius. And if you are taking the range 600 degrees Celsius, now the oven will increase the temperature maximum to the 600. And in case of 200, the temperature will go up to 200 degrees Celsius, and 600 temperature will go up to 600 degrees Celsius. So these are some controllers we are using for the range of oven. And you can use any range of oven that you want your temperature to up to 200 degrees Celsius or up to 600 degrees Celsius. And this oven is used to heat the sample. This is the panel meter here. This is the panel meter. So you know, in every apparatus there are some panel meter, they are showing some readings, and how they give the readings. So this is a digital panel meters, and how they are giving you the readings, because this panel meters is an instrument that displays an input signal in either digital or analog form. So there are some digital panel meter we use in the apparatus. It can be used in current source, voltage source, and the oven we are using. So there are digital panel meters are there in those apparatus, and how they give the readings. And because there are some sensors present in the apparatus, and the signals come from the sensor. When the signal comes from the sensor, input is converted into the digital form, and those parameters show you the readings. So there is a sensor present, and when suppose current is increasing, so sensor have a signal, and it convert that signal to digital form, and these digital panel meters show you the readings. So these are the panel meter we use in the apparatus for measuring voltage, current, and temperature. So these are the panel meters we are using. So in some kind, when there is a signal comes, and it gives a beep sound, and it gives the alarm options over there. So there are some panel meters like that, and but here we are using the digital panel meters. So now what is the theory behind this four probe experiment? So we are saying that we have to increase the temperature of sample, and we are using four probes for connecting our sample. So what is theory behind? You can see here, this is the sample that we are using in form of thin wafer. So four probes are connecting to these semiconductor material. Two probes, outer probes we are using to measure current, and inner probes we are using to measure voltage. And so this is a experimental, or this is a schematic diagram that we are using for this four probe. In case of conductors, when you increase the temperature, resistance increases. But in the opposite, when you have semiconductor material, when you increase the temperature, your resistance decreases. So this is the difference between semiconductors and the conductors. So if we placing our sample between the oven, and we are increasing the temperature, so what effect we will get? We will, with the increase in temperature, our resistivity should decrease. So we will see in this experiment that as you increase the temperature, resistivity of that semiconductor material will decrease. And in this case, we are using n-type semiconductor material we are using. So you have this formula, R equal to rho L by A. So you know, this is a formula. This is a formula for conductors, and this is the formula for conductor, that R equal to rho L by A, in which R is directly proportional to the length of that material, and inversely proportional to the area of cross section. And the constant of proportionality we get, that is the rho. Okay, so this is the resistance. We have the formula of resistance for conductor. So now what about the semiconductors, then because we are saying that its behavior is different from the conductors, so what effect will be there on the resistance instead of conductors? So there is a change in the formula for resistance. And what is the change? So this is the formula for resistivity then. And you can see here the change in the resistivity of your semiconductor material is just by this factor. This is the F, which is the function of W by S. So what is the W here? W is the width of sample you are using. Because we have a semiconductor material, we are saying that it is form of thin wafer. So there is some width of there is a width of that semiconductor material. And what is S here? We are using S for S is the distance between the probes. Okay, so how much they are apart from each other, these probes? So if you are saying it is S, so what is S here, and how much width of the sample you are using? You have this function, and this function is a divisor for computing resistivity, and this depends on W and S. So only the difference in the resistivity of semiconductor is only by this factor, and this factor is fixed for a particular arrangement. Because if you have any sample arrangement in the oven that we have placed over there, we have used 4-probe arrangement. So as we are using, it's fixed because we have used that probes at a fixed distance. S is fixed. The samples we are using, they have a fixed width. So this value of W and S is fixed for a given experiment. So this value of function will also be fixed. So what is this value? We are getting this value from the standard table, because when we made our experiment, so this arrangement will be made, so that what is the value of this function would be, so it is fixed. So when we are getting this value of function, which is the function of W and S, we can calculate the resistivity of semiconductor material. So now I will tell you how we are performing this experiment. You can see here, this is a theory of the this experiment, that in this experiment we have to determine the resistivity of semiconductor by 4-probe method. So you can see here this arrangement and the circuit diagram, and you can see here 4 probes have been used over this sample, which is in form of wafer. And these probes are equidistant from each other. 2 probes we are using to measure voltage, and 2 probes we are using to measure current. So this is the arrangement, and this is the circuit diagram for that. And now we are talking about the theory. So you can see here the formula of resistance, and the formula of resistance, this is for the conductor. So what we have studied earlier, that we are saying the value of resistance and the resistivity from the conductor is using this formula. And what about when you use semiconductor material? So the formula is only difference by this function. And now I will tell you about the, so you can see here with the black apparatus here, it is the oven that we are using to increase the temperature of sample. And our sample is placed between this oven. And you can see here from the variable there is option of cross section, and when you click on that, you can see the arrangement is there, which can be seen here. And there are 4 probes we are using, and the sample is placed in this arrangement, and this is placed in the oven. So you can see here, this is the arrangement we have in the oven. So now what will you do? And you can just tick over this cross section, and if you don't want to tick, you can just untick over there, because it is just to see the arrangement inside. So before performing this experiment, you have to select some variables, and you can see here the some readings are also seen here in the these 3 apparatus we have used here. This is the controlled oven. Current source we are using. We are using voltmeter. So current source give you the value of current, and voltmeter give you the value of voltage. And the controlled oven is there where we have also the range of oven is there, and controlled oven we are increasing the temperature. So this is the apparatus and oven we are using. And firstly, we have to select the variables to before performing this experiment. So firstly, we will select the material, if suppose germanium, and there is also you have to select the range of current. Okay, so you have two ranges of current. So if suppose we have used 20 milliampere, so if you have selected 20 milliampere, now the current slider, this is the current slider. So you can see here your the maximum value of current is 20 because you have selected the range of 20 milliampere. So the maximum it will go up to 20. So if you use 200, so the maximum will be 200. So and this is what the range of current. And in if suppose I have taken the value 5 milliampere from the current slider, and while performing your experiment, your current should be fixed. Okay, your current should be fixed while performing the experiment, and you can take any value of current, and we are taking here in the milliammeter range. So you can see here I have selected 5 milliampere, and you can see from the current source it is showing you 5 milliampere. So you can take any value. Okay, so but it should be fixed. It should be fixed while performing the experiment. So now here it is the range of ohm. So you can see here we have also a range of ohm there. It's multiplied by 1 and multiplied by 10. So I am using multiplier 1. Okay. So there is also now some buttons here: set, run, wait, and measure. Okay. So when you have selected the above ranges, you just then click on set button. When you click on set button, what now this oven will do, it will set your the temperature from the minimum value. If suppose it is showing here 25, so when you click on set, so it will set at now 25. So and what then you will do, because you have set your oven at the minimum 25, and now you can see that there is a temperature slider here, and it is showing your reading from 25 to 95. And what you do, you must select your temperature up to maximum 95 from the slider. And now selecting your 95, and if suppose you have you can also take 80 and 85, but it's you if you have selected suppose 85, now your oven will go up to maximum 85 because you have set firstly clicked on set. So the temperature has set the value of that semiconductor it at 25. But when you have clicked over, you have selected your range 85. Now your oven will increase the temperature up to 85. Okay, this is a range that you want to raise your temperature up to what maximum value you want. If you have selected 95, now your oven can go up to 95 because when you increase the temperature. Okay, so if you have selected 85, it will go maximum up to 85. So if you select only 40 and 50, so it will go maximum up to 50. So it will not increase beyond 50 if you have selected this range. So you just you must increase your maximum range. It can be 95, 85, 70 you can take, but it should not 40 and 50 because we want our temperature variation from 25 to high temperature. Okay, so you must take your this current temperature slider to the maximum. So what you will do then, you have to select the range also. If suppose you have selected 1 volt, and you can also select 100 millivolt. Okay, so if suppose you have selected 100 millivolt, and you are getting your value greater than 100 millivolt, so what this voltmeter will show you, so it will not show you any reading if your value is greater than 100 millivolt, and if it is less than 100 millivolt, it will show you the readings. And what happened when your value of the voltage is greater than 100 millivolt, it will not show you. So you just then in that case you just raise your range of voltmeter. So in that case now you can see, because when I have selected 100 millivolt at this particular temperature, so you can see here it's not showing you any reading, but because its value is greater than 100 millivolt, so when you selected 1 volt, now it is showing you the reading because it is greater than 100. So this is obvious. So you must you can change the range of voltmeter if you are not getting the voltage. So now what you have, we have selected the variable. So now what we'll do, and we will click on run. We will click on run. Now you can see on the temperature oven. Yes. Okay, so firstly, because when you have clicked on set button, your oven has set the minimum value 25. Okay, so now you have selected run, because when you have clicked on run, the temperature will now increases. Okay, now it has increased to 30, because you must have eye on this oven that how much value it is there. So suppose you get 30, then click on wait. Okay, so when you click on wait and measure, it will show you the reading. So you just write down the reading at 30 degrees Celsius, what the voltmeter you are reading of the voltmeter you are getting, temperature you have fixed. You have just increased the temperature and noting down the value of voltmeter. So then again run. Now you can see that temperature is increasing. Okay, so now it is at 35, just click on wait. So now you write down. Are you getting my point? So then again run, it is increasing. Yes, now it reaches 40, just click on wait. Then you just write down the voltmeter reading. So in this way you have to perform this experiment. Okay, so firstly you have to select all the variables. Temperature you have to vary, and we are measuring the voltage, and we are fixing the value of current. And you can take any value of current. It could be integer or it could be in points. You can take any value of current, but it should be fixed in a particular experiment. Then you just click on set button. It will set at 25. Then when you click on run, it will start increasing. So when it will start increasing, so up to, if you want your reading at 35, just then click on wait. Then if you want your value at 40, then click on wait. Okay, so this is how we have to perform this experiment. And in these observations, you have to take the fixed interval of temperature. Means you are not taking, suppose you have taken 30, then you are taking 36, or then you are taking 42. So that means your interval variation you are taking with for the temperature, it should be fixed. Okay, are you getting my point? If you are taking 30, then go to 35, 40, 45 means 5 degrees Celsius interval. And you can take 6 degree Celsius interval also, but that interval should be fixed. Okay, if you are getting 30, then 36, then go to 42, and then 48. So the interval should be fixed for every reading, and you have to take 5 to 6 readings for this. Okay, so but the interval should be fixed, and it could be 5, it could be 10, it could be 6, and it could be 7, but the interval should be fixed in your observation. Yes, this is the observation table that you have to make, and you have to take the temperature in degree Celsius. Then just take your temperature in Kelvin and the voltage you are getting from the experiment, and the value of current you have fixed. You can see here, this is the value of current, and this is the value of this function, and this is the value of W we are using, this is the value of S probe we are using here. So these values are fixed. Okay, distance between probe is fixed, thickness is fixed, current is fixed, and the value function we are getting from the standard table, it is fixed. So this is these values are fixed, and we are just varying temperature and noting down the values of voltage from the experiment, and your interval for this temperature variation should be fixed. And here it is showing 3 readings, but you have to take 5 to 6 readings, okay, with a fixed interval. So now what is the formula we are using? So you can see here, this is the formula, and we are getting voltage from the experiment. You are getting voltage from the experiment, and you have fixed the value of current, and you know what is S between the probes. So you can get the value of rho naught. So when you get the value of rho naught, then just divide by this function, and this value is also given to you. You can calculate resistivity.